What's the best part of class? Money setting up the cameras. Fantastic. Okay. So we stopped at number 4. Is number 4 horrible? What's going on with number 4? What am I asking you for?
What is the value of y when x is -1?
Yeah. So this one I say the input is -1, and I want to know what the output is when that's true. So you just plug the dumb thing in. What do you get? 4. Good. You get 3 times -1 squared is 3, minus -1 is plus 1 is 4. Okay. And what's this one want? The biggest mistake I get is somebody always plugs a 0 in, but that's not what it's asking. Yes.
It's asking when does the function equal 0?
When does this function equal 0, and how do I solve that? Yes. So whenever your variables, and this is not the only time this is true, but whenever a polynomial equals 0, the variables have different powers. I want to factor. If I can't factor, I try quadratic form or something else. Yes. So what comes out?
3x minus 1.
Oh, x comes out, and you're left with
3x minus 1.
3x minus 1. So you get x is 0, or x is,
1/3.
yep, 1/3. Add 1 divided by 3. How we doing so far? Nothing too crazy, I don't think. What's up? Oh, maybe.
Maybe.
I do. Now, I think that's, well, let's look at the bonus real quick. There is I wrote this a little, all right, this is going to come back very soon this semester. There is one problem with the way this is written, but it doesn't matter, because I'm trying to get at a certain point. What happens if you try to plug a 0?
It's 0 over 0.
You get 0 over 0. Now, what happens if I had 1 divided by 0 or 3 divided by 0? What is that? It's either called undefined or it's called infinite. Yes? So we'll stick with undefined. So anything divided by 0 is undefined. What is 0 divided by 7? 0 divided by 8? 0. So 0 divided by anything is 0. So what is 0 divided by 0?
Indeterminate.
Yeah, it's officially called indeterminate. I don't mind if you call it undefined, but it's sort of like 0 and undefined at the same time, which is why it's another level past undefined. It's what's called indeterminate.
Right.
Indeterminate is going to rule our life for a little bit of calculus. Not forever, but it's going to rule our life for a little while in a few different places in this class. Just to let you know, it's going to come back. Yes, sir.
Question: if you divide 2 identical numbers by each other, they equal 1, right?
Totally.
It doesn't apply to 0.
Hell no. Like, and real quick, let me show you. Real quick. 2 divided by 2 is the number that when I multiply 2 by it, I get 2. Like real quick, what's 6 divided by 2?
3.
Because 2 times 3 is 6. Yeah, so 6 divided by 2 is the number that I multiply by 2 to get 6. 2 divided by 2 is the number that I multiply by 2 to get 2. So what is that? 1. Is everybody with me?
Yeah.
So it's a slight reorganization of the words you use, but to be honest, it's a more technical understanding of what division is. What is 0 divided by 0 then? It is the number that, complete that. 0 divided by 0 is the number that when I, come on, no. 2 divided by 2 is the number that when I multiply it by the bottom, I get the top. 6 divided by 2 is the number that when I multiply by 2, I get 6. 0 divided by 0 is the number that when I multiply by 0, I get 0. Is there any wrong answer?
No.
Somehow, 0 over 0 is everything at once. Everywhere. Good movie. It's pretty racing words. Do you understand what just happened?
Yes.
2 divided by 2 is the number that when I multiply it by the bottom, I get the top. That's why 2 divided by 2 is 1. Why is 0 divided by 0 not 1? Well, if you apply the same definition, 0 divided by 0 is the number that when I multiply it by 0, I get 0. What number do I not get 0 when I multiply by 0? None. So what is the answer to this in a way? Everything. Could that be the answer? No. So that's why we call it indeterminate. I cannot determine the answer the way it's given to me. This will show up in places where we're actually able to do some manipulation and actually get a real answer, which will be nice. Are you guys all with me? I mean, you're not really, because you got to see this in action, but you with me in the case of 0 divided by 0 is weird. It is both infinity and 0 at the same time, and it's every number at the same time. What? Yeah, so it's weird. Okay. All right. At the very least, I want you to realize this is not simple. Okay. Okay, so this is indeterminate. That doesn't mean I can't get it into a form where I can determine an answer. There will be a problem with it, but I almost don't care. I'll point it out when we get there. I can multiply the top and bottom by the conjugate. That came up on number 1, I think. Yes? What would the conjugate of the top be? I'm going to write it over here. What's the conjugate of the top?
X minus 4?
No.
Rad of x minus 4.
No.
Rad of x plus 4?
Plus 2.
There you go. Same terms, different sign. That's all a conjugate is. And the only way to make that legal is to do the same thing to the top and bottom, of course. So when I do the top, half of x plus 4 times half of x plus 4 is a whole x plus 4. Okay, so don't make a big deal out of it. Minus 2 plus 2, the middles cancel. That's why we do it. Yes?
Do we need the notation of this stuff? Do we need the notation of this stuff?
The notation?
Yeah, do we need that for equals?
Oh, I mean, no. No, you can. There's nothing wrong. I'm just focusing on, yeah. So then, minus 2 times 2 is minus 4. And then you never multiply the other part. And you'll see why in a minute. What's the top become?
X.
And then what happens there?
Cross out X.
Taboo! So I get 1 over this, yes? So now, if I say this is f of x, I don't know if you guys can see that. Probably not. Okay. That's what f of x is, yes? What is f of 0?
0.
No, come on, you can do it.
4.
1 over square root of 4. Square root of 4 is?
4. 2.
What's 1 over 2 plus 2?
2. 4.
1/4. Okay. So the slight issue with what I just did, do you guys see what happened? I can't plug a 0 in because it makes the top and the bottom 0. What did I do on this step? I canceled the thing that was making both the bottom and top 0. What was wrong with the original problem? It came out to 0 over 0. We just talked about how weird that shit is. Do I want it to be 0 over 0? No, it's weird. I'll make a black hole somewhere. Okay. So if I can get to the point where I can algebraically manipulate it so that the thing that is making the top and bottom 0 goes away, then am I able to put a 0 in there? Yeah, and I get a number. Now the one slight issue with this is going to lead into something called limits that we're going to get into today. This step tells me I can't plug a 0 in, so to be honest, the real answer is undefined because I can't plug a 0 in because it makes the top and bottom 0. We're going to learn a thing called limits that approaches a number but never quite gets there, in which case we will be able to do this. But I just want to show you conjugates and other algebraic manipulations can get rid of something that is tripping me up. And then I'm able to do more than I was before. Okay. And again, this is bonus. This is not something I expected everybody able to do. What about this guy? Did anyone do number 2 here? Come back. What do I plug into tangent? What do I plug into any true function? Tell me something about what must be true of a thing I'm plugging into a true function.
So it gotta be an angle.
Gotta be an angle. There you go. So the input to a trig function is an angle. Therefore, what's the output to an inverse trig function? An angle, because inverses just switch the input and output. This is an angle then, which we knew already because it's inside of a cosecant, so it has to be an angle, but I just wanted to show you why it's an angle. This is an angle where what is true? All right, I'm going to take you down the whole step. Let me write this over here. I'll cry a little bit if there's anybody who's never seen this before, but I'll get over it very quickly. This is an angle. I'm going to call it theta for a second. So this equals theta. No, not 0, Jeff. Theta. Can you guys solve for 2 over x?
Yeah.
How do I do that?
Maybe like trying to
Okay.
give the x.
If you write x cubed equals 8, how do you solve for x?
Square root is cube.
Cube root,
Cube
yes.
root, yes.
So, say it again, you take a,
Cube root.
you apply the inverse. If I had x divided by 2 equals 7, how do you solve for x?
Maybe like
X divided by 2 equals 7. How do I solve for x? X divided by 2 equals 7. How do I solve for x?
multiply by 2.
Apply the inverse, that's correct. So how do I solve this for 2 over x?
Multiply.
I don't multiply, I apply. So I take the tangent of this. And of course, whatever I do to one side, I got to do to the other side, yes? What do these two do to each other? Kill each other. That's what inverse functions do. Come on. So this says tangent theta is 2 over x. Now, if you're actually doing this kind of problem, you shouldn't have to do this step. But I'm going to do this step now just to remind you guys, or maybe show you for the first time, hopefully not. Can you draw a triangle, a right triangle, that this is true for? How would you do that? What's tangent defined to be?
I don't know. That's right.
More basic. I have an x side, and I have a y side, and I have a hypotenuse. Okay. Where am I? I'm going to be very gentle. No, SOHCAHTOA sucks. It just does. If you know SOHCAHTOA, does anyone not know SOHCAHTOA? I love it. Stay that way. You're awesome. SOHCAHTOA's fine. It's fine. It just does one thing for you and never is useful again. If you know sine likes y, cosine likes x, you will go so much further. So tangent is y over x, yes? You with me? That's the definition of tangent. As long as my angle is in the base, this is the y side, this is the x side. So based on what this says, where does the 2 go? Total, here. Tangent's y over x. So 2 is y, x thankfully is the x side. So then, do you see how this right triangle has this angle living in it? Yes? Can I answer the question stupid easy now? What's the cosecant of this? Do I have everything I need to be able to get the cosecant? What am I missing to be able to get the cosecant? What's the cosecant's most basic fundamental definition?
Hypotenuse. You're missing the hypotenuse.
I'm missing the hypotenuse because what's the cosecant?
Uh,
Cosecant is related to sine. Sine is y over h.
right.
So cosecant is h over y. Do I have y?
Mm-hmm.
It's 2. Do I have h? No. Who helps me with that? Who helps me get that last side? Old Greek dude, yes. It'll forever be known as Old Greek dude to me. And very quickly, I have to say this. He didn't do it. His followers did it. He stole it. They were cult members, and that's fine. They signed up for it. So the history of math would actually make an interesting movie, believe it or not. So how do I solve for h? Oh, yeah, there. H squared equals 2 squared plus x squared. H is the square root of x squared plus 4. So can you now tell me what the cosecant is? Looking at the triangle, what's the cosecant? We just said it, right? Yeah, radical, it'd be h over y. Done. I don't know if you guys remember ever doing that kind of problem before. Hopefully you did, and you just forgot. Okay. I had to take a day off, Jack. I think it was that day. I don't think I understand. Okay. Again, that's kind of bonus, but still, that does every now and again show up. Yes, and if you take Calc 2, it's going to show up a little bit stronger. Okay. Any questions over that warm-up sheet? We did the other parts last time. Is that okay? Okay. So please, your God, try out chapter 1. Come with questions. Yes? There are bits and pieces. But let me say this before I forget, because I was helping somebody out earlier. What's homework? What's the first homework assignment? Where does it come from? Chapter 1, review. So the first homework assignment covers all math before now. So the first homework assignment is actually going to be kind of difficult. Not because the level of the work is high, but because it covers a lot of shit. You with me? So don't think you're like, oh, I can't even do the first homework assignment. No. The first homework assignment is all of algebra and pre-calculus. Go. Right? I'm not saying that to scare you. I'm saying that to give you a way to compare. If you're having trouble, that's about right. That's why we have the SISL. That's why we have office hours. Blah, 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 blah. Sorry, yes?
You know what time the SISL's open on Fridays?
It's not.
It's not open?
No.
Okay.
We're amazed we got enough budget money to open
Well,
at 10 to 4:30.
is the MSC or the?
MSC is open. I think it's 10 to 2 now.
Okay.
Yeah.
We kept creeping that up because, sorry.
I was just saying, I think that.
Monday through Thursday is 10 to 6. Friday, I think it's 10 to 2.
And then how late is it open?
We're going on the field trip today, so
Oh,
I'll talk
never mind.
around.
I'll skip to then.
The question of is it open on Fridays usually no or very?
The SISL, no. The MSC, yes.
Yeah, it closes earlier, but it's
10 to 2, I think.
yeah.
We'll find out for sure when they talk to us. Right? I have approximate knowledge of many things. Okay. Anything else before we jump into calculus proper? Because we haven't done that yet. All right, so this is very exciting for me because I just want to let you know this. Now that you're in calculus, I'm going to tell you this. Math starts at calculus. Once you learn calculus and you do anything else related to STEM, math, whatever, you're going, how did I do anything before I knew calculus? It's sort of like factoring. Once you learn how to factor, after that it's everywhere, yes? Because now we don't have to limit. We just sort of go, here's math, here's more math, blah, and there's like factoring is just what happens in the real world. And then we go, we didn't open up all the way. When you take calculus, now it's like calculus is what happens in the real world. Okay. So I don't tell people before they get to calculus. That would be a little mean. But it's also, I think I already told you, we only learn 2 things, but we do a lot with those 2 things. And those 2 things are very different from the math you've done before. Related to pre-calc is such a dense class. So much is in pre-calc. There's not as much in calculus, but they are conceptually a little bit higher. So what you're going to need to do in this class more than ever before is to really understand the idea as you work the problems. Because the more you understand the idea, the easier the problem's going to be. This first idea kicks a lot of ass. And I did the homework out of order because I don't like how they introduced this one topic. But has anyone ever seen the movie The Blob? And I'm talking about the 1980s. Anybody ever watch? Yes, you know what I'm talking about? You don't have to. Can you imagine what it is? Horror movie? Huh?
What's it on?
What streaming service is it on?
Streaming service
I don't
is it
know.
on?
Tubi.
Okay.
Is it
I
about
don't
which
know.
line?
That's something. I think it's something. It's on the YouTubes. But basically, a meteorite crashes to Earth. This guy's walking along. He's like, "What is that?" And he reaches out and he touches the damn thing, and then the movie happens because the little monster comes out, goes around his arm, eats him, and goes to the hospital, and he eats everybody else. Okay. Yes. A few people survived. It's got to, otherwise, yeah. Alright, is everybody kind of with me? So why am I talking about that when I just said I was going to start talking about calculus? Here's why. What would we do if you saw a meteorite crash to Earth and you saw it kind of moving a little bit? Would you touch the damn thing?
No.
If you would, you deserve that shit. But I would. Knowing me, I would be like, what the what? I'd be right here and I go, oh, that's weird as shit. Okay, I'm gonna report that. Get me out of there because it could be radioactive. But I'm gonna want to take a look. I'm gonna, oh, okay, and then I walk away. Yes, I'm gonna get close to investigate the unknown. I'm gonna get close. I'm not gonna touch it because I watched enough of those movies. Yes. Very good. Now, how does it relate to what we're about to get into? Let me ask you this. Where are my glasses? Oh, I swear to God. What if I had... Oh, yeah, let me do this. Let's start here. Let's start this a little bit backwards. What if I wanted to investigate this question? I want to know what's going on with this at x equals 1. Yes? What is it? Is the answer 0? Indeterminate, yes? Okay, so we're going to apply the blob business to this problem. Instead of touching it, plugging 1 in is like touching it because we got to 1. We're not going to get to 1, we're going to get close to 1. Yes? Okay. So, if I make a little table of values, I'm going to call this f of x just so I can reference it really easy. Can somebody give me a number that's close to 1? Do it again?
0.99.
Yeah, let's not get that close yet. Let's start a few steps back, yes? But I appreciate you know where I'm going with this. Let's do 0.5. Right, so it crashes to Earth. I'm about here and I'm like, I get half a foot away. Ooh, okay, I feel that. So then maybe I'll get a little closer to look at it. Yes? You guys are kind of with me? So I'm at 0.5, that's pretty close to 1. And then I can get a little closer. And then I can get a little closer. Now I could do this forever and go slightly insane, but let's stop here. So what we're doing is, if I plug those values in, I'm observing, what's the only, for that function I gave, what's the only input that has a problem? 1. So every single input I'm considering now, will it work?
Yeah.
Totally. If I try to plug 1 in, I get worse than undefined. Yes? Okay. Can you guys help me? Can you guys do those real quick? Do you have a calculator?
Put the function in.
Put a 0.5 in, put a 0.9 in. Yes? Some of you guys might know some shortcuts. You can use the table in your calculator. If you don't know that, I'll show you eventually. Is this right? Negative some 40. What is happening? Wait a minute. So I need you to do, the function is x squared minus 1 over x minus 1. So are you doing 0.99 right now? Oh, okay, I got you. Yeah, you're fine. You're fine. What's up? Did anyone do 0.5 yet?
It's 0.25.
What'd you get?
1.5?
1.5? Yes? Okay. Because that would be 0.25 minus 1, 3/4, negative 3/4 over 1/2. Yeah, 1.5. I just had to. Should be negative, yes?
Yeah, negative 0.75?
No, I'm sorry. The two negatives cancel. It should be positive, yes?
Yes.
Okay. What about somebody else? Somebody else 0.9. Did anybody else do 0.9? Are you guys doing that right now? Yes.
Negative 5.
Negative 5? Yeah, I think 1.9.
Yeah.
Yes.
To double check what happened. 1.9 sounds right. And then what about 0.99? 99? Huh?
1.9.
1.99.
No.
That's it?
Yeah.
Okay. Alright, so that is like me getting close to this thing from this side. Are you with me? Have you guys ever seen, oh gosh, today was just horror movies. Somebody's in the bed and there's somebody coming behind them and the camera goes around to the other side. We can see it's a little monster and the person can't. Yes? So they get really close, they're like, it's a human, it's a human, it's a human. If only they would have come from the other direction, they would have been like, it's a demon. Okay, back. So, do you guys see how we just got close to 1, but just from the left side? If you plotted on a number line 1, didn't we just approach it 0.5, 0.9, 0.99? We just approached it from the left side. So how do I do the same thing but approach it from the right side? What number's going to plug in to get close to 1 from the right side? 1.5, 1.1, 1.01, yes? All right. Let's have all of you guys do 1.5. Everybody in the middle do 1.1, and everybody over there do 1.01. Let's knock this thing out. You guys are doing 1.01. You guys are doing 1.1. You guys are doing 1.5. Did my 1.5ers get anything? What'd you get? 2.5? Is that what anybody else got?
I got
That sounds
1.5.
sounds about right. Yes. Okay. 2.5. What about my 1.1ers? What'd you get? 2.1. Does that sound right? Everybody else? Sounds right to me. Okay. 2.1. I like your crowdsource work here. What about 1.01? What am I 1.01? 2.01? 2.01? And you can kind of guess that pattern from what happened over there. Now, thankfully there's no demons here. Yes, as you do a math problem, you're not going to get sucked into some vortex of intelligence. At least I don't think so. That hasn't happened that I know. We got really close to 1 from the left side. We got really close to 1 from the right side. Do they seem to both be agreeing on something in the middle? What number do they seem to be agreeing on? 2. So as I get close from this side, close from that side, my best guess, the actual answer could be 1.9999999999973. I don't know, but what's our best guess based on the evidence we have? 2. Do you guys see that? Both sides agree that it looks like it's going towards 2. We don't know for sure because we could get closer, right? And right at 1, it freaks the shit out. So we can never know exactly unless we do this more algebraically. Yes?
What's the difference between like a limit and like an asymptote?
Oh, well, let me introduce limits first. And then we'll talk about how limits help investigate and arrive at asymptotes. So that question doesn't really make sense because you guys did horizontal asymptotes. You guys remember horizontal asymptotes? Horizontal asymptotes are a type of limit, and so are vertical. So we'll get there. Okay. So what is this limit thing? I am trying to investigate this function at a value. The way to represent that mathematically is I am trying to take the limit of the function outputs as x goes to 1. If you look at it, we were trying to figure out what are these approaching, and we call that the limit. In the limit, you're approaching this, so that's the limit. Yes. If you wanted to obey the speed limit, you could approach it and not go past it. So that's kind of like why we call this a limit. It's what I seem to be approaching. Okay. To write this more mathematically, which means with less words, We don't write the whole word limit, we just write LIM. We write the as x goes to 1 underneath it, and we write the of f of x next to it. So this means, what is the limit of the outputs as x goes to 1, or even better, without using the word limit, what value do the outputs approach as I let x get close to 1? You guys coming with me? That is all this symbol means. This symbol literally directly means do this. Do you all agree though that 2 is a guess? Do you see how 2 is a guess? Because the answer could be 1.99999 or whatever. Yes? We don't know for sure. So let me do things a little out of order like I always do. If I look at this again, let me write the whole question from the beginning. That's the question from the beginning in calculus speak. Yes? Is there something algebraically I could do? Sort of like that first bonus problem where you did the conjugate. Can I do something algebraically to this to simplify it? What can I do?
Put 1 on x.
Hmm?
Put 1 on x.
What can I do with this? So that parts of it will cancel.
Factor?
Factor it! So how do I factor x squared minus 1?
It's going to be x minus 1, x plus 1.
That's crazy. Now, here's the key part. Here's the key part, and I made a point of this earlier. What is the only value of x that the x minus 1s cannot cancel? Remind me, is 0 divided by 0 1? No. Yeah, the only value of x that I cannot cancel these is 1. Remind me what this means. Do I ever let x equal 1? The whole idea of a limit is weird shit happens in 1. So let's not go to 1. Let's get really close. Right? So I'm allowed to cancel the x minus 1s here because I never get to x equals 1. Die. So what this means is, real quick, watch this. This is really dumb. You ready? What did we just figure out this function is equivalent to except at 1? X plus 1, yes? Look back at the table we made. What was x? 0.5. What's x plus 1? 1.5. X is 0.9. What's x plus 1? 1.9. Didn't this effectively, the function was x plus 1? Isn't that what it did? We just verified it algebraically, yes? Yes, sir.
So that's why it looks, when you graph it, it looks exactly like x plus 1.
Yes.
And the only way you can tell the difference.
Here, I'll graph it in a minute. I'll show you how you can tell the difference. And then this is dumb. What happens to x plus 1 if I let x get really close to 1? 1 plus 1 is 2. So if the limit, if there's no problem at this number, I'm allowed to just plug it in. Because then I can go there, yes? If there's just a patch of grass there, there's no meteorite that landed, can I go into the patch of grass?
Yeah.
Can I step on it if I want to? God, you great star. Or plug it, or just look at it, or whatever. You guys with me? If there's a meteorite there, I don't want to touch it. Okay. So if the function I'm evaluating has no trouble, how do I tell very quickly what it goes to? I just plug it in. I just let it get there then. I can let it get there. Are you guys all with me? Here, I couldn't let it get to 1 because it gave me 0 over 0, which is freaky as shit. Now, what we did a second ago is interesting. Let me see if I can come up with a decent example of this. Did I skip somebody's question? No. Okay. Let's do. Yeah, let's do that. Yeah. Okay. Let's do. Yeah. Okay. Say what? Say what?
Does limit mean it can never equal 1?
Yes, I can't let x be 1. But I really want to make sure you understand this. Didn't I let x be 1 to get to? It's because this says, oh, I can't let x be 1 because something freaky happens here. But if I simplify it, nothing freaky is happening. So to figure out what it looks like the function's doing as they go to 1, I could just let it be 1. Because there's nothing freaky going on with this guy. Okay. It's kind of quick little side note on that because I'm not sure this is what I want to do right now. If I just gave you f of x is x plus 3, what's f of 3? 6, crazy. So what's the limit as x goes to 3 of x plus 3? Well, it's just freaking 6 because if I approach 3, I'm going to get outputs close to 6. I know I am because the function is x plus 3. I really want this to make sense. Limits only have to be applied in their full capacity of not approaching the number, not getting to the number, if this guy has an issue, like the first problem did. Algebraically, we remove the issue. So now I'm allowed to just plug a 1 in. So the limit of silly things like this is just another way to write f of 3. Because there's no problem here, I'm allowed to just put a 3 in. There's no problem there. Okay. Let me think. Maybe this will work the way I want. No, it won't, will it? Oh, let's do this. Here, wait. I can save it. There we go. Make that x squared. Okay. So let's do this together real quick. In fact, let me show you how to make a table in the calculator if you don't know. Okay, so if you have your calculator, get that sucker out. Go, do it, yeah. First thing I want you to do, if you go to table set, which is right above window, change this to ask. Right there, independent variable, go from auto to ask. Now go to y, is everybody with me? Go to y equals and put that function in. Sine x divided by x squared. If you go to table now, it'll be blank. Yay, Jeff, thanks. But now I can make my XY table. So I'm approaching 0, yes? Give me a good number to investigate that. Huh? Sure, 0.1. Now get closer to 5 from the right side. I'm sorry, closer to 0 from the right side. I kind of gave away 0.05, 0.01. Yes, is that cool? So we're getting close to 0, yes? And then you can see very quickly what this is doing. What about from the other side? You could do it, Jeff. Negative 0.1. Let me do it. I always do this backward just because. Negative 0.01, negative 0.05, negative 0.1. Because now I can kind of do this. Do they look like they're approaching the same thing?
Yes.
You sure? Are you sure? Let me zoom in. I am zoomed out a little bit. Focus. So if you do this, are they approaching the same thing? No! It's got a major problem, don't it?
Yeah.
What problem does it have?
One of them's positive, one or the other.
One's positive, one's negative. It's got an even bigger problem than that, though. Oh, I'll tell you what. Was I just dumb? I probably was just dumb. This is neat. I can't pretend like I did this on purpose. Is my mode? Oh, good. Thank God. It is radians. You definitely want to be in radians. Yes. Okay. Thank the gods. All right, guys. So, what would you say the limit is then? What would you say this limit is? Does this limit seem to exist? So, tricky question to ask you out of nowhere. Did they agree from both sides?
No.
So from one side it's going to negative and the other side is going to positive, yes?
Yeah.
So does the limit as I approach that thing of the function? Does it seem to exist?
No.
Do you see why? To exist, they gotta both agree. Oh yeah. You know, let's meet at the gas station, and then we go, and the gas station is there. Yay! If I say let's meet at the gas station, and you go here, and I go there, I'm like, our meeting place does not exist because we are at two different places. Are you with me? Okay, maybe. Are you guys semi with me so far? Okay. All right. Yes, I want to make this a little more graphical for a moment. I want to look at a limit problem graphically. Keep an eye on the time. Okay, I want to give us a break here in a bit. Okay, everybody draw this roughly. And then I'm going to try to get us all to put a scale in here. Let's see. This could get trippy because I didn't do a great job. Okay, I think I might have salvaged it a bit. Yes, I think I did. Has everybody got that? Like the open circle should be at the 5 height, and the closed circle should be at the 4 height. You guys see that? Not the best graph ever made, but. So it is very obvious which inputs I would need a limit idea to investigate. Which inputs needs that? Which inputs require a limit idea to investigate? Do I need help for an input of 1? Is its output weird? Okay, which inputs have weird outputs?
Maybe 3.
2
3.
and 3. 3 definitely weird, yes?
Yeah.
Because somehow that thing teleported. Yes? We were driving along, we hit a pothole, and we ended up here somehow. Yes? That's new. Didn't know City Council could approve that. So, let's look at this guy first. Tell me again, what's the central idea of a limit? What is the big thing I talked about?
In approaching
It can never get to the value it's investigating, right? The limit is x goes to 2. Does it ever actually get to 2? No. So could the limit, if I'm looking at it from a limit perspective, would it ever know there's a hole there? Does it get to 2? Could it ever know there's a hole there then? Can you imagine there's a trapdoor right there, yes? There's a trapdoor right there. And I'm like, hey, how's it going, how's it going? And I get right up to the edge, and then I walk back, and then somebody comes the other way, and they stop right at the edge, and they walk in. Do we have any idea? No, but if I step on it, and you're like, whoa, and I'm gone. Then you're like, oh, yeah, it's a trapdoor. It's in the room downstairs. Are you guys all with me? So what is the limit? As x goes to 2. And I'll call this g of x just to be different. What do the outputs look like they're doing as the input approaches 2? So right here, this input is close to 2, yes? And the output is there. This input is close to 2, and the output is there. As I approach 2, what are my outputs approaching? 5. Does everybody see that? There's for some, I'm a little far removed, but I notice some students sometimes are like, I'm not, what are you talking about? You have to look at it in 2 different ways at once. I'm approaching 2, but I'm keeping an eye on what are my roads doing? What are they both approaching? Not they have to get there, but what does it look like they're approaching? It looks like they're approaching 5. Yes?
Is it negative 2 or 2?
I'm sorry, negative 2, thank you. Is that what everybody's... I just wrote 2 there and I just ran with it, so just showing off all my awesome math skills. Yeah, I just decided to go with reality. Negative doesn't exist, so I don't have any depth.
So when you put -2 for the x under the limit?
Yes, thank you. Alright. So as I approach -2, the outputs approach 5. Does everybody kind of see that? Okay. Because if I'm here, the output is here. If I get a little closer, my output gets closer to 5. So as I let the inputs approach -2, the outputs approach 5. Why does it not matter there's a circle there? There's an open hole. Like what is f of -2? I'm sorry, what is g of -2 then? What is g of -2?
Doesn't exist.
Beautiful. Undefined, I would say. Undefined. You guys see that? G of -2 is undefined. Why is the limit 5 then? Because it only approaches. It just says it looks like I'm going to 5. G's job is to say, where am I? Limit's job is to say, where does it look like I'm going? The limit says, it looks like we're going to 5, and the G says, you fell through a hole, man. You are gone from this universe. You guys with me? Because I could think, I'm approaching that piece, I'm approaching this part of the room. I'm approaching this part of the room, and then I fall through trap door. Did I make it to that part of the room? Did I make it to that part of the room? I'm gone. But was I approaching that part of the room earlier? Yes. It may be. It's not the best analogy, but not all of math becomes physical easy. Sorry.
So is the limit identifying the hole then?
No, the limit has no idea. Watch this, you ready? Does everybody understand what's going on? Again, I don't know if I said this to you guys. If I introduce an idea in class, my tone could sometimes come off as, come on, understand this. I'm always trying to show you how it's not as hard as it seems. But this is the first time some of us ever seen this shit, so it does take a while to let it sink in. So don't let my tone make you feel like you're supposed to know it. Yes? Just let it in. Whatever. If you're not fully there yet, you're a lot closer than you were about 15 minutes ago. Yes? Okay. What was your question again? I'm sorry. That's a good tangent.
Is the limit of -2, is that identifying where the hole is?
No. So here. If everybody understands this, you ready? This would have the exact same answer. The limit would still be 5. Same answer. But now what would this be?
5.
Yes, because now it actually gets there, yes? This is, where does it look like it's going? This is, where does it actually get? Completely different things. This has no idea how it got there. This has no idea if it got there. Does that make better sense?
So why identify the limit as -2 at all?
The limit is x goes to -2?
Yeah.
Because we have some way to know something weird happens there. We're not sure what it is.
Okay.
So when I take a limit, I go, oh, it's trying to be 5.
Okay.
And that could be information based on what my function represents. Yes? Okay. So what about this guy? This guy, we're going to have to introduce something we haven't talked about, like, symbolically yet. What's up here? You must like where I'm going. So I could talk about going to 3, but I'm going to talk about going to 3 from the left, and I'm going to talk about going to 3 from the right. See the little minus and plus? Remember when we made the table? The first limit thing we did, we made a table, and we approached from the left, we approached from the right. So now symbolically, that's what that looks like. And you see how, when investigating something like this teleportation, this kind of what's officially called a jump in the graph, I need to kind of investigate it from both sides. So what does this mean?
Means left.
Left.
Tell me fully.
As you're approaching the number 3 from the left.
As I approach the input of 3 from the left, or as I input numbers below 3 or less than 3, what are my outputs doing? Yes? Is that cool? Okay. And what is happening? As I put numbers in that are less than 3, what are my outputs approaching? 4. With my horrible scale and shit, but it's approaching 4. Do you guys see that? Mm-hmm. Okay. Do you guys see that? Do you guys really see that? So I want to be on the road that's below this. I want to be on this road. The road that's below 3. That's the negative. So what's the limit as x goes to 3 from the right? The road that's above 3. I'm sorry. I should say to the left and to the right. When I say above 3, I think this. Some of you guys might think this, so I gotta be careful. What if I go on this road? So I go to the right of 3. From the right of 3, what is my, oh, I didn't say, did I? Shit. Let me continue my scale down here. There. All right, now, what could the answer be? So as I approach 3 from to the right of 3, as I approach it, what do the outputs look like they're going to? -4. But what is g of 3?
It's gonna be like undefined. Right?
No, come on.
No.
What's
Four.
g of 3?
Right, 4. My bad.
What's g of 3?
It's 3.
It's 4. Yeah. Because what's the output at 3? 4. Yeah. There's a defined output at 3, yes? So it doesn't care that it jumps. Because remember, the output has no idea what's going on around it. It only knows what's going on right there. So it's at 3, it's at 4. That's all it knows. The limit is like freaky shit going on around you, man. Sorry?
Sorry, that looks like 3.6. Like, those are just hard to tell.
I know, I did a horrible job. But you're fine. Yes.
So if the bottom one was solid, it would be -4?
Yes. If that was open and that was closed, then the output would be a -4. If they were both open, then the output for g of 3 would have been undefined. It's not a function then, yes? What does it not pass if both of them are closed? Vertical line test. And then it's not a function, yes? Okay. And if I ever give you that problem, you can say, Jeff, you gotta stop.
So how do we know which one's gonna be open and which one's gonna be closed?
Oh, it'll be given to you.
Okay, on the
Yeah.
right.
Yeah. So I can give you a limit problem algebraically. I can give you a limit problem using a table. I can give you a limit problem graphically. Let me stop for a second here. The idea of a limit is not that intensive. It is new. It is very new, and there's a couple parts to it where you have to train your brain to think about it the right way. But you guys agree with me, even if you don't fully understand it, it's definitely not crazy math.
Right.
It's remarkably useful. It's stupid powerful. You have no idea. Right now you're like, just playing around with where the open thing is. No, it's dumb how much you do with a limit. There's so many times we have functions that don't work somewhere, but I can investigate what's going on still. And I can get more information about it. Anyway, sorry. I get a little crazy. What about this? Let me do this real quick here. I'm just going to do this just to... Here. There. Nobody can complain too much. Complain a little bit, I guess. And this is h of x. What's the limit as h goes to a? I'm sorry, what's the limit as x goes to a of h? B. Somebody with me? Again, limit has no idea what's happening at a. All it knows is what the roads are doing. They look to be going to B. What's the limit as x goes to a of h? Now, what's the limit as x goes to a of h?
Still
Nope.
would be B, right?
That is h of a. I didn't ask for h of a. What's the limit as x goes to a of h of x?
It's still B, right?
It's still b.
Yeah.
Because what do limits not have a clue about? What's happening at, in this case, a? Has no idea. So I could put the dumb point anywhere. It could be here, it could be right here, it could be here, it could be there, it could be there. The limit will always be b in every single one of those situations. Because are the roads, did I move the roads? No. Aren't they always approaching the same place? In every single position I could put that point? Limits only know what it looks like this is approaching. It has no idea if it actually gets to. So where the closer hole, or even if there is a closer hole, it has no idea. It can't know. It wasn't built to know. Maybe. Okay.
Is the limit taking a guess at what's happening on y?
Yes. I mean, especially with a table. We're guessing. With a graph, it's a little more definitive, especially if you got a better scale and it's more obvious. The graph pretty much, even then, you could argue you're guessing. Yes. And then algebraically is the actual answer because you're not guessing that.
Yeah.
Okay. So let me do this. I've got a handout. If you don't like handouts, you're really going to hate this semester. Let me give this to all of you. I want you to work on the side that's got the graph. Yes? The side that's got the graph. I get gonna give you three.
Yeah.
I did. Give me one. Oh shit, that's all square.
Thank you.
Anything. That, see? Yes, that works. I know what I'm doing. You have extra?
It's just, no,
You're supposed to have extra. You got one?
I got one, yeah.
Did you get one? Oh, man. Alright, everybody got one? Okay. Alright, so, guys. Look at this by yourself first. Just kind of look over the whole thing. Look at it by yourself first. And then in a few minutes, I'm going to ask you to like group up with at least one of the person. Kind of like compare notes. Yep. So just try this graph problem out first. This guy. Oh, oh, you're good. I'm fighting that.
I'll try not to do that.
I think I'll give us a break when we're done with this. It's number one.
Can I ask you a question?
Yeah.
What is the difference between?
Let me grab my glasses. Just a sec. Go! Okay. I think I got around to almost everybody. So this says if I let my inputs get closer and closer to -4 from the left. So if I pick an input, look at the output. Pick an input, get closer to -4. Look at the output. Pick an input, look at the output. They all are approaching an output of 2. Done. So the limit is asking, what are your outputs approaching as you let your inputs get close to this thing? And what I try to show a few guys is you can start to just look at the road itself. The limit is all about what the road looks like it's doing. So if I go from the right, if I follow the road, which again is just doing this just a little bit less crazy, it still looks like it's going to 2, yes? The outputs are still approaching 2. If I go here, it's gotten closer to 2. The output is closer and closer to 2. Kabam! The minute you know the left and the right are equal, then the limit as I go to -4 is 2
Yeah.
in this case, because they both agree. So that is the limit. If I said we both drove to the place and we had the meeting there, does the meeting place exist? We both drove to the place and we met there. Does the meeting place exist? There, done. If they don't meet, the place they meet doesn't exist. That's why we call, if these were different, like we'll see in a minute, I would call this does not exist. But in this case, it does exist. They're in like a big old pothole, but you know. All right. So that limit does exist, and that limit is 2. But what's happening right at an input at -4? What's the output at -4? Undefined. Kick ass. So the function value doesn't have to have a damn thing in relationship to the limit. They look at the thing in 2 completely different ways. What's it look like it's going to? Have no idea if it gets there. Where does it get? Have no idea how it got there. Maybe. I like some of you guys are looking at me like, please start making sense. Does he start making sense? Okay, but some of you guys are okay. Some of you guys are human beings. I like it. All right, now what if I approach 1 from the left? So again, if I do it this way, approach 1 from the left, I can see my outputs are getting closer and closer to 4. If I approach 1 from the right, though, freaky ass things happen. My outputs seem to be getting closer and closer to -2. So therefore, where's the meeting place? Where the 2 roads meet? Does not exist. Their meeting place does not exist. Yes?
How's it different from undefined?
Let me think. Undefined means specifically, at that point there is no output. A limit can't use that same word because it doesn't know what's happening at a point. It only knows what's happening as I travel towards it. That's one way to think about it.
Okay.
Yeah. But it also, when I said meeting place and all that kind of stuff, there's more technical language I could put there that would explain the word exist a little bit better. Technical language is a little bit beyond us. Yes?
I was also wondering about E. I wasn't sure that it was going to be 4 because it approached actual numbers.
Oh,
That
totally,
doesn't
that's
matter.
fine.
Okay.
Yeah, again, let me think. If this was an open circle, the limit would have no idea I made it open because the limit doesn't have a clue what's happening at the input. So if I made that open and I made that closed, nothing about the limits change. But what is F? I'm sorry, go ahead.
So even if the top one is solid, it does like they still don't have like a meeting point.
Do it again.
So the bottom one is hollow, the top one is solid. So it's still not going to be 4 even though the top one is solid. The point.
The limit?
Yeah.
These don't meet.
Okay.
So the limit there can't exist. Because from one direction it looks like it's going here, and from the other it looks like it's going there. So if I said, where does it look like the line is going just in general? You said, it doesn't exist. What are you talking about? It doesn't look like it's going somewhere. They don't meet. Does that make sense?
That makes sense.
Okay. What's F of 1? 4. These questions kick ass. You gotta let these questions be old news. Look at an input of 1. Is there a closed circle? Yes, done. These questions, let them be easy. If there's an open circle, there's no closed circle, undefined. Woo! What about as I go to 6? From below it approaches, the output approaches 5. From above the output approaches 5. So the limit, I could just consolidate that and say it just is 5 no matter which direction you come from. But what is F of 6? 2, because again, all it cares about is where did the function go and went to 2. Can it get there? If you're on a road, if you're in a car, can you get here? No. So you got a helicopter here. This is some, really rich person that's up to the top mountain. You got a helicopter pad, whatever the shit, whatever. Okay. Maybe you guys are with me. So F of 6 is 2. So let's take a break. Let's I don't know. What do you guys want? What do you guys want? Come back at 5? Is that 5:05? Come back in a couple weeks? No. Come back at 5:05. I'll give you 15 minutes.
All right.
What about, how do we do on this problem, guys? Guys? Hopefully somebody did this, yes? Now that you know how to make tables in your calculator, why the hell wouldn't you? I'm not sure. Oh yeah, okay. Notice something, since it's symmetric, it kind of reinforces my guess. But do you see how, if you needed to, you could certainly get closer to 1. Yes? 0.99999999999. Just put that in there. Get close. But what's a good guess for what the limit as we go to 1? What's a good guess for it?
1.
1. So as I go from this side, it's getting closer to 1. As I go from this side, it's getting closer to 1. They both seem to agree, so the limit is 1. And again, if we do it this way, we can't know for sure. It is a guess based on observations, based on data. Algebraic manipulation, I get an exact answer. Yes?
So if you had a function that was like y equals x per se, or maybe, yeah, let's just say y equals x, could that have a limit? Because it's technically like they're approaching the same.
I need you to really understand. I want to make sure you understand. I have to use limits to investigate weird places.
Okay.
If I have a function that is not, what's the limit as x goes to 1? 2. Is this weird in any way? Does it have any? So every single point can be described using a limit.
Right.
Where must I use a limit to investigate things when there's weird shit happening?
Okay.
If I have a graph, I can tell where the weird shit's happening. If I have just a function, and when I graph it, maybe you guys can imagine this. There are graphs that you really can't tell what's happening. Oh, I forgot to do that thing earlier. Let me do it now. Because that's exactly what I'm talking about right now. Remember earlier we had x squared minus 1 divided by x minus 1, yes? Do you guys remember that? That was today, okay. If I graph this thing, let me make the zoom 6, okay. Do you guys see a problem at 1? Does that look like it's got a problem anywhere? No. The reason is, when we draw an open circle, that is huge. That's not, huge is not even the right word. Because how big should the open circle be? 1 pixel. And I'm talking about in the infinite resolution of the universe, that should be 1 pixel, yes? So infinitesimally small. So how can I make the calculator tell me there's an issue at 1? Do you guys know how to make the calculator tell me what the output at 1 is? If we go to second, calc, value. And I say, what's the output at 1? Watch what it says. No, wait, let me do this. What's the output at 2? 3. Yes? If I go second, you could do it, Jeff. Second calc, no, you can do it, Jeff. Second calc value. If I say 1, watch what it does. You ready? You ready? What's the output?
Nothing.
Open circle. How big is that open circle? 1 pixel in the infinite resolution of the universe. Are you guys with me? So that's why I can't see it with my naked eye. Are you kidding me? Especially with my naked eyes. I only have one eye that really works, but that's all right. Okay. So that's kind of cool. This is how an open circle looks like on our graph, on our calculator, because it represents it better. We over-represent it because we're freaking like, I want to see that shit. Okay. Maybe. So, I don't know if anybody turned it over to these guys. I know a few of you guys got to the back here, but how many of you guys did not try any on the back out yet? Anybody? A few of you guys. Did most of you guys? How many of you guys did try the back?
I thought we were supposed to be doing that.
How many of you guys don't like raising your hand? Because I get about 70% of the class didn't say one or the other. I'm like, that's logically impossible. You have to be one or the other. So if you didn't try this out, can you try 1A out? Go ahead, try 1A out. So this is not graphical. This is not table. This is algebraic manipulation. Oh, so the limit, that's still here. That should be here. It should be here.
1 over something.
And now, it's kind of like, all right, real quick. If I said the square root of 4 squared plus 9 squared, and I said, okay, that's 16 plus 81, that's 97. Am I right?
Yes.
No, because it's the square root of that shit, yes?
Yes.
So the limit of this, the limit is still there. The limit is still there, limit is still there, and you're not done until you've done that limit. So you got one more step. Because what am I trying to let x go to? And you can do it now at the end. You can just put a 3 in. because you've eliminated the problem. Yeah, so you're not done until you actually evaluate the limit. Yes. Yeah, same thing. So this limit, what I was showing him was like if I x squared 3 squared plus 4 squared, and I said, okay, that's 9 plus 16, that's 24. That's not right. Because the answer should be square root of
X
that.
will just cancel out.
So this should be the limit is still there, limit is still there, limit is still there. Now you can apply the limit
Oh, I got it.
at the end.
Okay.
One little thing though.
I gotta review
Yes.
my
Oh, okay.
Okay.
Thank you for that.
Sure.
I gotta review my discount. How did you cancel out?
Well,
Because I'm not
the
getting
funny
this.
thing is,
Now I
it
get
didn't
it.
say
This is where got it.
you should always question that. Basically, that's what we did. Why do we know when to try to use a conjugate factor? Is if I get zeros or something.
Yeah.
This would be okay. Total. And now you know to actually simplify. On this problem, I kind of gave away the game that these are all indeterminate.
So
Because I said
just
simplify first.
Okay.
But like, if that was a x minus 4,
Okay.
this would be 0 over negative 1.
Did you check the show solutions?
I wouldn't have to do shit. That'd be dumb. That's why you always try to plug the number first to see if you even have to do anything.
Yeah.
Because if it's not determinate, then it must be determinate. I can determine the answer.
Yeah, good, exactly.
Multiply this, multiply the two fractions, you're gonna get a negative, the fractions are gonna cancel out, right?
Yeah, that's what I was trying to
So
tell you.
now, it's gonna be negative x, negative 9, the two nines go away,
then you have to do
negative
something.
x, and then x in the top, x in the bottom.
Yeah, this one you have to
And
factor.
this is what we get.
This one you have to use something else.
Plug in
This
our
one you have to use something else.
limit, plug in our limit, you see those two cancel out. We're gonna plug in our limit.
Why? Okay, because it's
Oh,
all.
this makes sense now. It's just, I gotta.
Get those fractions together first.
No, I didn't.
And then how you
Plus
divide
ones,
fractions.
The conjugates and stuff, I'm kind of forgetting it. I forget how everything works for the conjugates.
There are other ways to do that problem, but I
I
think
gotta
it's the
see, we
most
do
work.
everything.
So here's the 3,300. What happens is this negative is gonna, so it should be 9 minus x minus 9. Yeah, I mean, you're gonna end up in the same place, but it should be 9, yeah, minus x minus 9. So then the x should be negative. There we go. You kill those, and now you're allowed to do this because you killed the problem. It's not a life lesson. Don't kill your problems in real life, just in that.
Just hope.
Nice. Except, where did that come from? 3 plus 3 is. No. Yeah, you're good, you're good. I know you don't believe that. Yeah, you just left that out, that should still be here. The example I was giving you was this question, and somebody did this. No, the root should still be there, I'm not done until it did it, the limit is still here, it's not done until you did it.
This makes sense to me. This one is still kind of hard. I'm
What
figuring,
did you guys
I'm
get
not
the
gonna
limit
photomath
first?
You can take a 4 out of this first.
What did
right?
you get the
Do
limit
a
for
GCF.
C?
Or you take 2 out of each piece, which is.
1 over 16?
Yeah, at some point you'll get it. Well, you only have 2 x's, so I'm not sure you have 2 here and 2 just hold it. Yeah. So choose 2x minus 6, so we have 6. And then you can factor it out.
Wait, how did you get the 16?
Alright. Alright, well hopefully if you did A, you kept going.
I said that,
Um,
but I didn't get the limit.
So guys, this one, the limit, listen. The limit must go with you. Always. Because it's still there. This shouldn't go away until you've done it. And what am I doing first? I'm factoring. I'm not doing the limit yet because I can't. Because what happens when you plug a 3 in? Did anybody do that? Did anybody plug a 3? Yeah, you get 0 over 0, which is why you have to simplify first. So, I can take a 4 out. Then I can factor this business. Yeah. And then when I plug a 3 in, real quick, do you see how both of these are 0 at 3? That's why I had 0 over 0. Now that I've killed them, I've killed the problem, I can plug 3 in now. I couldn't before because these were there. They're not there anymore, I could plug a 3 in. So what did I get when I plug a 3 in? 24. Cool. So on limit problems that we do by hand, algebraically, we're trying to get to a point where the reason I can't plug the number in cancels. And then remarkably, I can plug the number in because I killed the problem. So over here, do I factor? No, what method do I use here?
Conjugate.
Conjugate. Never multiply the conjugate except what it's a conjugate with. So don't multiply the bottom out. Don't distribute that shit. It just makes it really horrible. Up here I get 3 times 3 is 9 minus, now here's where everybody makes a mistake. I gotta subtract the result of this. So your 9 should cancel. Negative x over 2x. What happens here? X is canceled. So that makes the top 0. That makes the bottom 0. Now I can plug in 0. I'll get negative 1 over 2 times 3 plus 3. I'll get negative 1/12. Is that cool? Kick-ass. Kick-ass. Okay. This one, everybody's favorite. Has anybody tried this one yet?
You tried it.
I hate
The most direct way to do this problem, there's several different ways. Get the two fractions on the top together. How do you guys do 1/3 divided by 7/9?
You make the
1/3
same.
divided by 7/9. How about 1/3 divided by 7/11? There you go. When you just multiply by the reciprocal.
Yeah.
So if I had one fraction up top, I could then just multiply by the reciprocal of the bottom and be done with the damn thing. So I'm gonna get the top to be one fraction, so I can do that shit. So what is he missing that he's got? Oh, the second guy's missing an x. What's the first guy missing?
The 2.
Another factor of 2. So then I get 2 minus x over 4x over 2x minus 4.
That's right.
Whoops, sorry. You guys gotta let me know. I'm zoomed in. You guys with me?
Yes.
Just LCD. So now I could do the limit. Here, let me do this for you guys. One thing I was letting people do, because I don't necessarily enjoy writing all this out, is just to make a big L for your limit. Just so you don't forget that there's something to do there. You can make a big L. And so this will be 2 minus x over 4x times the reciprocal of this. Now, what the hell do I do with this?
Factor out something.
I can factor something out of here, but if I want to be smart about it, I can factor a negative 2 out, because then the result will be this, and those can just kill each other. You guys see that? If I factor a 2 out, these don't match up. Damn it. So let me factor a negative 2 out. These dumb things cancel, which is the whole reason I couldn't plug a 2 in, because it was, 2 minus x. So when I plug a 2 in, what do I get? You can do it, guys. When you plug a 2 in, what do you get?
6,
No.
8,
1 over negative 1 over 16.
Yes. You can plug 2 in, you get 8 times negative 2 is negative 16, under 1, yes. Yes. If you got 1 over 8? No, I can't simplify this anymore. Did I miss something? Let me see. Do you see how these canceled? I have a negative 2 here. When I plug a 2 in, that's 8 times negative 2 is negative 16. You can't escape 16. It is coming for you. Yes.
What was the answer for A again?
I don't know.
24.
24, yeah.
Yeah, that's what I got. Let's go. Sorry.
You're in the same room as us.
Here we go.
Oh, no. 2-1 we haven't talked about yet. Sorry. I don't know if anybody tried 2-1 out yet. Don't look at 2-1. That's the last little piece I'm going to talk about here for a bit. Okay, so we can evaluate limits in several different ways. 3 different ways we talked about that. Using a table, given a graph, algebraic. Yes? I want to give you an example problem that I didn't think to put on here, but it's because I had a different thing I wanted you to investigate. What would you guys do here? And what would you do here? What?
Equals, factor?
Separate the top.
Difference of square.
Factor, or difference of, yeah.
Nope. What do you get when you plug a 3 in?
Oh, you don't have to even do it.
You don't have to do that shit.
You can just,
What do you get when you plug a 3 in?
you get,
0 over 1, so the answer is 0. All right, so the idea here is, when is it? What was the word I used? If the problem would have been this instead, if the problem would have been what you guys sort of assumed it was, what happens when I put a 3 in? 0 over 0, indeterminate. So what's the opposite of indeterminate?
determinate?
Determinate, which means if it's not indeterminate, I can determine the answer immediately. So if it's indeterminate, I go, shit, I gotta do something, factor, or conjugate, or put the alright. If it's not indeterminate, I can determine the damn answer, and I can be done with the dumb thing. So this one is not indeterminate, it's 0 over 1, I'm done, it's 0. There was no problem at 3. Did the function freak out at 3? Nope. Therefore, the answer is 0, I'm done. You guys see that? You guys see that? Real quick, is everybody cool with the fact that I can put 1 in here? Why? Why can I do that?
It's determined.
It's determinate, sure, but what's the more immediate thing I said? Does x plus 1 have a problem at 1? No. Does this have a problem at 3? No. How can you tell if it has a problem? Plug it in. So before, if I give you a limit question and I just say evaluate the limit, the very first thing you should do is, do I have to do any work? Let me just plug the number in. If I get 6 over 2, it's 3, I'm done. If I get 0 over 0, damn it, I got to factor or do some shit. You guys understand? If the function has no issue, I can evaluate a limit by just seeing where it's going, because it's gonna get there. It's got no problem. If it's got no problem at a point, it's gonna get there. So I can just plug the number in and see where it's gonna go. Right? What's the easiest way to see where a road's going? You drive down the damn thing. And as long as there's not a giant crater, I'm gonna get somewhere. Yes? If there's a crater, then I gotta investigate. Then I gotta bring a limit in to help me. Okay. Maybe. Yes.
Could you show
Let's see. Yeah, so I got LCDs. So 2 times 1 minus 1 times x over 4x. I got the LCD of 4x. I gave this first guy a 2, and I gave this other guy an x, so they both had a 4x on the bottom, and now I can put them together. Yes, and then when I did that, how do I divide fractions? This fraction divided by the reciprocal of this fraction, yes? And then I just factored -2 out of the bottom, so these canceled, and then I just plugged it to it. Because once these guys cancel, the thing that was making it indeterminate died. So then I can just plug the number in. What are we doing? I guess. No, sorry. If you want to, man. This was conjugate stuff, and the one mistake people make is to forget the negative's got to go through the whole x plus 9. So if you got x minus, or 18 minus x or something, like, I don't know what to do with this, the 9 should have died.
I was just gonna ask, why does, on the top, when it comes to -x, why is it -1?
Oh, because the x is canceled. What's x divided by x?
Oh, because the x
No,
is-
no, I was just.
Yeah, x divided by x is 1.
Yeah.
There's a 1 there. Okay. So, last thing for today, this is huge. The reason I do 2-2 first is because 2-1 gives the game away a little bit. Limits exist. Limits have a billion different purposes. For calculus, their most important purpose is what 2-1 is all about. But if I start with 2-1, what I notice is students start to think, oh, limits mean this thing. No, limits are just limits. You can use them for a lot of different shit. We're going to go and we're going to talk about one thing you can use them for. Let me lay a little groundwork. And then around 5:30, we're going to walk and look at some stuff. How do you find the slope of a line? Somebody cool with that? I have an input, I got outputs. How do I find the slope of that line?
Distance formula.
Yes. So output at the second minus output at the first divided by
x2 minus
the first input minus the first output. Yeah. The first input minus second. Above. Whatever. Y2 minus y1 over x2 minus x1. Just written a little more formal. Yes? So here's the trippy thing. Lines are kind of silly because the minute you know the slope somewhere, that's the slope forever. If the slope changed, it wouldn't be a straight line. It would curve.
Right.
What we do in calculus is we say, has anyone ever been or ever heard of a roller coaster before? How many of you have ever been on a roller coaster? If you've never been, I'm sorry. Do you all agree that at every point on the roller coaster we're headed in a direction? It's just that direction is constantly changing, yes? So, click, 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 and here's Jeff like, what the shit did I get on this stuff? Click, 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 holy shit, when do we ever get, click, 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 and then, yeah! So at every point, what's the slope here? What are we doing? Slope is what? What's the only thing you can tell me about the slope right now? Positive, kick ass. What is it now?
Negative.
What is it here?
Zero.
Right? Do you see how even though a curve, it seems like you can't get the slope of a curve because the slope is constantly changing. But at any given point, isn't there a certain slope? Right? So what we do in calculus is we somehow, what do I need in order to find the slope? I need 2 points, yes? What did I just say that we're going to try to do in calculus? I want to know the slope at that point. What would algebra say if I asked it that? Hey, algebra, here's 1 point. What's the slope? What's algebra going to say? Go home, sweetie. You're drunk. What happened to you? So what do? We know limits exist. So I want the slope at 1 point. Algebra needs me to feed it 2 points. Yes? So what we do is something really neat. We say, okay, let me step away from that point a little bit. So here's the point. Let me draw this better. God damn it. Let me come over here. Okay. So here's the point I want to know the slope at, yes? And I step away from it a little bit. X plus h. H is some small value. Do I have 2 inputs now? Do I? What are the outputs? Well, that'll be f of x. What'll this be? F of x plus h. It's crazy. So what's the slope officially between those 2 points?
F of x2 minus.
And what happens on the bottom? It's the second input minus the first, yes? So what happens though? Now, this is so sweet. I need you to understand. We want the slope here. Because we're crazy ass calculus students. Algebra says, so we're like, oh yeah, okay, algebra, calm down. Here's 2 points. What do I do next? Because I still need the slope at that x input. I want the slope right there. So what am I gonna do next? What am I gonna, you guys can do it. Is that point close to this point? Is that input close? Could I get closer?
Yeah.
Wouldn't it be great if I got like really, 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 really close? Because that would be really close to just one point. Do I have a process that does that? I don't know, the thing we've been talking about the whole day. What am I gonna let the limit as what goes where? What do I want to go to something? What is keeping it from being one point? There's one variable up here, yes? Not h versus x, no. If h was what, I'd have 1 point. How do I make this equal that? If h was 0. So h is how far away the second point is. If I did the limit as h goes to 0, won't the second point become the first point? Won't I have 1 point then? But do I ever have 1 point? I'm letting the limit as h goes to 0. So is the separation ever actually 0? No, because again, what's the whole idea of a limit? Will h ever get to 0 if I have the limit as h goes to 0? No, that's the whole idea, yes? The limit, it doesn't let the input get there. So algebra is forever happy. I'm constantly giving it 2 points. But I'm letting them get so stupid close together, I'm effectively seeing what's the slope at that point. Maybe? So if I taught that first, you guys would all associate limits with this idea. And I wouldn't blame you. But now we know limits exist, and here's a situation where we're like, wait a minute, limits would help. That's the right way to think about this. I have a thing I want to have happen. I have a tool that will help me do it. Yay! Okay, maybe. That's it. Okay. Oh shit.
It's a limit.
God damn. I get so wrapped up in talking.